Dear students, welcome. Today we shall discuss the multivariate calculus. In the last class, we proved 8 important vector identities. The remaining vector identities will be proved today. Let us try to solve the identity number 9, which goes as, which is curl A cross B. Curl A cross B. This is equal to B vector dot nabla A minus B divergence of A vector minus A dot nabla B plus A divergence of B vector. We are going to prove this one. Curl of A cross B equal to B dot nabla A vector minus B vector divergence of A vector minus this one. The proof will be like this. Curl of A cross B. This is equal to curl of A cross B. This is equal to, you may write nabla cross A cross B. This is equal to I cap delta delta x, j cap del del y plus k cap delta delta z cross A cross B. Cross A cross B. This is equal to I cap cross del del x of A cross B plus j cap cross del del y A cross B plus k cap cross del del z of A cross B. You may write like this, or in summation notation you may write in this way. You may write like this. You may write like this. This is equal to summation I cross A cross delta B by delta x plus del A vector by del x cross B. You may write in this way. Now you see A cross delta B by delta x, del B by del x, it is a vector quantity because cross product of two vector is a vector quantity. It is also cross product of two vector is a vector quantity. Since vector product is distributive, therefore you may write I cross A cross delta B by delta x. It is distributive. I cross del A by del x cross B. You may write in this way. You may write in this way. Since A cross B plus C, this is equal to A cross B. This is A cross C. Now, this can be written as summation I cap cross A cross delta B by delta x plus again summation I cross delta A by delta x cross B. You may write like this. You may write like this. Next, this can be written as summation I cap dot delta B by delta x A cap A vector minus I cap dot A vector delta B by delta X. You may write plus. Similarly, I cap dot B vector delta A delta X minus I cap dot delta A by delta X B. Since A cross B cross C, vector product of three vector, vector triple product, this is equal to A dot C B minus A dot BC. This has been applied here. A cross B cross C equal to A dot C B minus A dot BC. This has been applied here. Now, this is equal to summation I cap dot delta B by delta X A vector minus summation I cap dot A vector delta B by delta X plus summation I cap dot B vector delta A by delta X minus summation I cap dot delta A delta X B vector. You may write like this. You may get this. You will get this one. Now, you see, this can be written as, which is equal to summation I cap del B by del X dot A vector minus, this can be written as A vector dot I cap, because dot product is commutative also, delta B by delta X. You may write like this, plus B vector dot I cap delta A delta X minus, you may write I cap dot delta A delta X B vector. Right like this. What is this? I cap dot delta B bar delta X. It is nothing but divergence of B vector. Divergence of B A minus A vector dot summation I cap delta delta X B. You may write in this way. Plus, here also B vector dot summation. Since it is I cap, you will write summation. A vector minus, it is nothing but, what is this? I cap dot delta A vector by delta X plus J cap dot delta A vector by delta Y plus K cap dot delta B A vector. It is nothing but divergence of A vector B. Divergence of A. It is nothing but divergence of. This is equal to divergence of B A vector minus A dot nabla. It is nothing but nabla. I cap delta delta X plus J cap delta delta Y plus K cap delta delta Z. It is nothing but delta B plus B dot nabla A minus divergence of A B vector, which is nothing but this, which is equal to B vector dot nabla A minus B divergence of A. This is equal to, you may write B vector dot lambda A minus divergence B divergence of A. B, write B first, then it will be divergence of A. Again minus A vector dot nabla B, A vector dot nabla B plus A divergence of B, A divergence of B. Therefore, we have proved the factor identity number 9. We have proved the factor identity number 9. Later, we have proved this one. Now, what is number 10? Let us try to prove the factor identity number 10. Number 10. Gradient of A dot B. Mind that gradient of a scalar function is a vector function. A dot B is a scalar. Gradient will be a vector. This is equal to B dot nabla A plus A vector dot nabla B plus A cross curl of B vector plus B cross curl A. You will get this one. B cross curl of A. Now, proof. What is the proof of this? Gradient of A dot B. Gradient of A dot B, which will be equal to, just write, it is nabla A dot B. You may write in this way. This is equal to I cap delta delta x delta x plus j cap del del y plus k cap delta j A dot B. A dot B. This is equal to I cap del del x A dot B plus k cap del del j A dot B. A dot B. Right? You may write it as like this also. A dot B. Can I write like this? A dot B. Now, differentiation, it will be A dot delta B by delta x plus delta A delta x dot B. You may write like this. Or summation A dot delta B by delta x plus delta A by delta x dot B I cap. You may write I cap. You may write like this, which is equal to summation A dot delta B delta x plus dot product is commutative, therefore B dot, you may write B dot delta A delta x I cap. This is equal to summation A dot delta B delta x I cap plus again summation B dot delta A delta x I cap. What is this? In the left side, you may write gradient of A dot B. Gradient of A dot B. Now, let me remind you, this has been vector triple product has been applied in the previous vector identity also. This is equal to A dot CB minus A dot BC. This has been applied in identity number 9 also. We have this one. Therefore, what is this? This means A dot BC will be equal to A dot CB minus A cross B cross C. You may write like this. You may write like this. Therefore, here, put this bracket here. Therefore, A dot BC, A vector dot delta B by delta X I cap should be equal to A dot C, A dot I delta B by delta X minus A cross delta B by delta X cross I cap. You may write like this. This is equal to A dot I delta B by delta X. This will be plus. If you write the plus sign, then I cap cross, you may write. Since A cross B equal to minus B cross A, since A cross B equal to minus B cross A cross B equal to minus B cross A cross B equal to minus B cross A. Therefore, summation A dot delta B by delta X I cap should be equal to summation A dot I delta B by delta X plus summation A cross I cross delta B by delta X. Now you see, you may write like this, which is equal to, this is equal to A dot summation I cap delta delta X B plus A cross summation I cap cross delta B by delta X. You may write like this. This is equal to A dot nabla B plus A cross. It is nothing but curl of B vector by the definition of curl of B vector. I cap cross delta B by delta X plus J cap cross delta B by delta Y plus K cap cross delta B by delta Z. This is equal to this. Thus, we have got the summation A dot delta B by delta X I cap equal to A dot nabla B plus A cross curl of B vector. Curl of B vector. Similarly, summation B dot delta A delta X I. This one delta interchange A and B here. Just interchange A and B. you may write here number 2 and number 3. Number 2 and number 3. Using 2 and 3 in 1 we get. Using 2 and 3 in 1 we get. We get gradient of A dot B. This is equal to this one. For this, you may write the bracket here also. For this, you may write like, you may write this one. A dot nebula B plus A cross curl of B vector. Curl of B vector. For this, write this one plus B dot nebula A plus B cross curl of A vector. Therefore, we have proved the important vector identity number 10. Let us try to solve the vector identity number 11. We have solved this one. Number 11. Vector identity number 11. What is this? Curl of A vector equal to curl of a vector is a vector quantity. Curl of another vector quantity will be again vector quantity. It will be gradient of divergence of A vector minus A vector. You see the Laplacian operator. Let me remind this one. Delta square delta x square plus del square del y square plus del square del z square. Laplacian operator. If it is phi is a scalar function, then it will be delta square phi delta x square plus delta square phi delta y square plus del square phi del z square. It is scalar, means this will be scalar. This will be scalar. If it is vector, then this will be vector. This will be vector. It is vector means this will be again vector. It is vector means this will be vector. It is scalar, therefore it will be vector quantity. You see divergence of A vector is a scalar quantity. Gradient of this scalar will be a vector. It is vector, it is also vector. Curl left side vector quantity, the right side will be definitely vector quantity. Now, curl of A vector equal to gradient of divergence of A minus nebula square A, Laplacian operator. Or you may write in this way also. Curl of A vector. This is equal to gradient of divergence of A minus. In this way also you may write this identity. It also the curl A vector. This is equal to gradient of divergence of A minus nebula square A. Let me prove this. To find the curl of a vector quantity, therefore you should write let A vector equal to A1 I cap plus A2 j cap plus A3 k cap. You should write like this. Therefore, curl of A vector will be equal to the determinant I cap, j cap and k cap, del x, del y and del z. A1, A2, A3. It will be like this. This is equal to This into this minus this into this, just like that. You may write del A3 by del y minus del A2 by del z I cap plus, now remove this one, write the delta A1 by delta z minus delta A3 by delta h j cap plus delta A2 by delta x minus delta A1 by delta y. Okay. You will get this one. Curl of A vector equal to this. Curl A vector equal to this. Now curl of A, therefore curl A vector equal to, again you may write like this, I cap, j cap and k cap, del x, del y, del z. For this you may write delta A3 by delta y minus del A2 by del z, del A1 by del z minus del A3 by del x and del A2 del x minus del A1 by del y. This is equal to del y of del A2 by del x minus del A1 by del y minus del z A1 by del z minus del A3 by del x I cap. You may write I cap plus for j cap del z of this one del A3 by del y minus del A2 by del z minus del x of this one del A2 by del x minus del A1 by del y. Act number 1. Yes. j cap plus del x of this one del A1 by del z minus del A3 by del x minus del y of this one del A3 by del y minus del A2 by del z. It is k cap. It is k cap. Let me calculate this one. This is equal to, you see, del square A2 by del y del x minus del square A1 by del y1 square. It will be del square A1 by del z square also. You should write here del square A2 by del y del x. First write this one. Next write this one. What is this? Minus plus del 2 A3 by del z del x. Del 2 A3 by del z del x. This one. Minus delta square A1 by delta y square plus delta square a1 by delta z square. You may write like this. I cap. It will be I cap. Now see this one. First write this one. Delta to a3 by delta z delta y. Write this one. Next you should write this plus delta to a1 by delta x delta y. 1 minute. Number 1 minute. Here delta to a2 by delta y delta x. It is delta to a3 by delta z delta x. It will be minus plus. It will be plus. Here it will be plus. Next write this one and this one. Minus with a minus sign. Delta to a2 by delta z square plus delta to a2 by delta x square. Z cap. This will be z cap. Plus first write this one delta to a1 delta x delta z. Next write this one minus plus delta to a2 by delta y delta z minus delta to a3 by delta x square plus delta to a3 by delta y square. This z cap. We have got this one. Now we are evaluating curl of curl A vector. Now this is equal to you may write delta to a2 by delta x delta y and plus delta to a3 by delta x delta z. Now add this one delta to a1 delta x square. Add this one minus here also you should add this one. I got a vector has continuous second order partial derivatives. Assume this. Now for this plus you should write delta to a3 delta y delta z plus delta to a1 delta y delta x plus delta to a2 by delta y square minus here delta to a2 by delta x square plus delta to a2 delta y square plus delta to a2 delta z square. We make it like this because this has been added and subtracted. Result will be the same. For this you may write delta to a1 delta x delta z delta x plus delta to a2 delta z delta y delta z delta y. This one plus add delta to a3 by delta z square. Add this one. Also subtract this. Also subtract this one. get this one. You will get this one. Now, which is equal to, for this, del x of delta A2 by delta y plus del x of del A3 by del z plus del x of delta A1 by delta x, delta A1 by delta x. You will get this minus delta square delta x square plus del square del y square plus del square del z square A1. You get I cap. Can I write like this? Definitely I can write like this. This one. For this plus delta delta y of delta A3 by delta z plus delta delta y of this one delta A1 by delta x plus delta delta y of delta A2 by delta y. This has been written minus, you may write delta square delta x square plus delta square delta y square plus del square del z square A2, and it will be j cap. And finally for this, for the last step, you may write delta delta 0 delta A1 by delta x, A1 by delta x plus delta delta 0 del A2 by del y, A2 by del y. For this, del 0 A3 by del z minus delta square. You will write like this. No. You see this one, del x. You may write here del x. First write this one, delta A1 by delta x. Next write delta A2 by delta y plus delta A3 by delta z, A3 by delta z minus minus just as it is, you may write like this. A1, this is I cap. A1 I cap. Can I write like this? Plus, see the second step, delta delta y of. Again, you may write delta A1 by delta x. Next, delta A2 by delta y plus del A3 by del z, del A3 by del z minus, right, A2, this is j cap, plus for this you may write del 0 del 1 by del x plus del A2 by del y plus del A3 by del z minus del square del x square plus del square del y square plus del square del z square. A3 it is k cap. A3 it is k cap. Enumerate like this. Now you see I cap delta delta x. Now let me write it this in this side. Now this is equal to I cap del del x of this plus j cap del del y of this del del y of this plus k cap this k cap del del z of del del z of this of. Now you see this one same del a1 by del x plus del a2 by del y plus del a3 by del z. This one minus del square del x square del square del y square del square del z square. For this 3 it will be a1 I cap plus a2 j cap plus a3 k cap plus a3 k cap. It will be like this. Now what is this? This is equal to nabla. It is nothing but divergence of a vector. Divergence of a vector minus it is nothing but nabla square a vector. Since if a equal to a1 I cap plus a2 j cap plus a3 k cap, I have already proved this. Then divergence of a vector is equal to del a1 by del x plus del a2 by del y plus del a3 by del z will be equal to this. Then this one. It will be divergence of a vector. This is equal to, you may write, it is gradient of divergence of a vector minus it is nothing but Laplacian operator. This can also be written as gradient of divergence of a vector minus, you may write like this. Therefore, we have proved this theorem also. Perhaps you have understood this one. We have proved 3 important vector identities today. Let us try to solve one another. Let us try to solve a problem. Prove that. Suppose you are given prove that nabla square x by r cube equal to 0. Nabla square x by r cube equal to 0. Nabla square x by r cube. Perhaps you have understood this one and you have enjoyed that class also. You are enjoying. Now, nabla square, we have proof. Nabla square x by r cube. This is equal to, you may write del square del x square, del y square plus del square del z square. X by r cube. X by r cube. This is equal to x by r cube plus x by r cube plus nabla z square x by r cube. What is this? X by r cube equal to this. Suppose this is number 1. Suppose this is number 1. Now nabla square, del square, del x square, x by r cube. This can be written as del x of you may write like this, which is equal to del x of, it is the product function 1 by r cube into 1 plus x minus 3 r to the power minus 4 del r by del x. You may write like this with respect to x. This is equal to first function this, the differentiation of the second function x, function x, r 1 by r cube means r to the power minus 1, r to the power minus 3, minus 3 r to the power minus 4. With respect to x, you will have to write this one. This is equal to del x 1 by r cube minus thrice x by r to the power 4 del r by del x means x by r. You may write x by r. Since r square is equal to x square plus y square plus z square, therefore 2 times of r del x equal to twice x. This means del r by del x equal to x by r. Del r by del x equal to x by r. Equal to x by r. This is equal to del x of one by r cube minus thrice x square by r to the power 5. It will be like this. Thrice x square by r to the power 5. Now, what is this? Minus 3 r to the power minus 4 delta r by delta x minus 3 x square minus 5 r to the power minus 6 delta r by delta x, del r by del x minus 3 by r to the power 5 into twice x. First function x square, second function 1 by r to the power 5 means r to the power minus 5. You may write like this. This is equal to minus 3 1 by r to the power 4, just like this, del r by del x equal to x by r. You may write x by r plus 15 x square by r to the power 6. It is again x by r minus 6x by r to the power 5. 6x by r to the power 5. This is equal to minus thrice x by r to the power 5 plus 15x cube by r to the power 7 minus 6x by r to the power 5. This is equal to 15x cube by r to the power 7 minus 9x by r to the power 5. We have got this one. Therefore, delta x square x by r cube, this is equal to 15x cube by r to the power 7 minus 9x by r to the power 5. Suppose this is number 2. This is number 2. Now, we have obtained x by delta square of delta x square x by r cube. Now, delta square delta y square x by r cube, what will be this? This is equal to del del y of delta delta y of x by r cube. X by r cube. You see, you are differentiating partially with respect to y. X is constant here. In this case, x is constant. H minus 3 r to the power minus 4 del r by del y. Del r by del y. This is equal to delta delta y of minus thrice x by r to the power 4. It will be y by r. It will be y by r. Since r square equal to x square plus y square plus z square. This means twice r del r del x equal to twice y. This means del r by del y. Del r by del y equal to y divided by r. You will get this one. It will be y divided by r. Now, which is equal to minus thrice x. It is common del y of y by r to the power 5. Y by r to the power 5. It will be again product function. This is equal to minus thrice x, right? Minus thrice x. Y minus 5 r to the power minus 6 del r del y plus 1 by r to the power 5 into 1. You will get this one. This is equal to minus thrice x. You will get minus 5 y by r to the power 6 y by r plus 1 by r to the power 5. 1 by r to the power 5. 1 by r to the power 5. Now, this is equal to minus thrice x minus 5 y square by r to the power 7 minus 5 y square by r to the power 7 plus 1 by r to the power 5. Therefore, delta square delta y square x by r cube will be equal to 15x y square by r to the power 7 minus thrice x by r to the power 5. Minus thrice x by r to the power 5. You will get this. Right? Suppose this is number 3. Similarly, from this, delta square delta z square. In this case also x is constant. X will be regarded as constant if you differentiate this partially with respect to z. This is equal to 15x z square by r to the power 7 minus thrice x by r to the power 5. It will be like this. It is number, suppose 4. Using 2, 3 and 4 in 1 we get. Using 2, 3 and 4 in 1 we get. Using 2, 3 and 4 in 1 we get. Two, 3 and 4 in 1 we get. X by r cube. What is this? It was this 15x cube by r to the power 7 minus 9x by r to the power 5 plus it will be 15x y square by r to the power 7 minus thrice x by r to the power 5 plus and this one. It will be 15x z square by r to the power 7 minus thrice x by r to the power 5. This is equal to this one, this one, this one. 15x by r to the power 7, take it common. X square plus y square plus z square. Minus x by r to the power 5. 9 plus 3 plus 3. You will get this. This is equal to 15x by r to the power 7 into r square minus x by r to the power 5 into 15. This is equal to 15x by r to the power 5 minus again 15x by r to the power 5 equal to 0. This is equal to 0. Therefore, Laplacian operator lambda square by x by r cube. This is equal to 0. Therefore, this is equal to 0. We have proved this one. Dear students, perhaps you have enjoyed the class. I want to stop here. Thanks for attending the class. Thank you very much. Thank you.